Hi and welcome to your next chemistry lesson. In this lesson, what I want to do is I want to take a look at the periodic table, and especially the one that you will encounter in your tests, and a very simple one that you should be able to understand. And you will find that it is actually not that difficult, or even though it looks a little bit complicated. The first thing that I want to tell you is that you will notice that the periodic table is divided. First, they are sequenced. The elements are sequenced according to their atomic number. You remember the atomic number is the number of protons that they have. Okay, so they're sequenced according to their atomic number in rows, almost like you would be reading. So there's 1, 2, 3. Okay, so each time a proton is added, it just moves up. Okay, and now each time we move into a new energy level, we'll just move into a new line. So what that means is that the row number represents the energy level. So for example, this is energy level 1, which hydrogen and helium occupy. Energy level 2, we've got lithium, beryllium, okay, boron, carbon, nitrogen, oxygen, fluoride, and fluorine and neon. Okay, they all go up to energy level 2, and then so forth up to, as you can see, we've got our 7 energy levels represented by the 7 rows. Now, the previous video we looked at valence electrons. Valence electrons are the number of electrons in the highest energy level, and they are represented by the column number. So for example, you'll see there's 2 different types of column numbers. We've got the normal numerals, and then we've got the Roman numerals. These are normal and our Roman numerals. We will primarily focus on the Roman numerals. These will be their group numbers. Okay, but nevertheless, the column number represents the number of valence electrons. Remember we said that tells me how many electrons I have in my highest energy level. So for example, we've got, it's oxygen, is a fun one. This is the Roman numeral for 6, a 5 and a 1. That's 6. Oxygen has 6 valence electrons. He wants 8 valence electrons because he wants to be noble, which means oxygen would like to add 2 electrons to his group, okay, of electrons. Okay, that is the columns and the row numbers. Now let's just look at the symbols. The symbols are very important, so I do want to stress it. You need to know what each symbol represents, so I'll go through the most important ones quickly with you. So this is hydrogen, helium, lithium, beryllium. We'll go up to the first 30 about. Boron, carbon, nitrogen, oxygen, fluorine, neon. This one is a little bit confusing. That's sodium. Okay, sodium, and though it's in A. Okay, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Again, another one with a weird symbol considering the name, although it's not weird in different languages. Okay, but in English it is. This is potassium. Okay, calcium, I think scandium, titanium, vanadium, chromium, manganese, Fe, again, what on earth? That's for ferrous, which is, I think it's the Latin word for steel, for iron. This is, so this is iron, cobalt, nickel, copper, zinc, and we'll only go up to zinc, and then there's a few more that I want to highlight. For example, we should know all of group 7, which has a special name, we'll get to that, and group 8. So this is bromine, iodine, and no, you can forget that one. Then helium. So let me just highlight these extra ones. Okay, then we get in the last column, as we've already done, helium, neon, argon, krypton, and xenon. Okay, I'll highlight them as well. Then the next row we've got a few important here. For example, here we have Ag, that's silver. Okay, silver, this one also comes up quite regularly. That one is cadmium. Okay, he comes up every now and again. We've done those. Let's see what else here. Oh, there we go. That one's easy enough. That's platinum. And yet this one is again the opposite end. Not so simple. That's gold. Okay, then this is mercury. That's that metal that you find in thermometers. Measures the thermometers measure heat. Then we've got lead. Again, a strange symbol for it. Okay, but those are the most important. So it is important that you know the symbols as well as that you know what each of the symbols represent. Okay, so we have the symbols. Then we also have the approximate relative atomic mass. So what is that again? Well, you remember that if that is the protons, the number of protons, okay, this is the number of protons plus neutrons. Okay, so each atom may have a different number of neutrons. Okay, so not even though all atoms, or for example all oxygen atoms have the same number of protons, not all oxygen have the same number of neutrons. So some oxygen has more, some has less. Okay, so when it comes to relative, what they mean by that is that this is a rounded number. There's more decimals supposed to be there, so it's approximate. When it comes to relative, what they mean by that is this is not the exact number. That's relative based on the type of average that they've taken. Let's just say that much. That's all that's really important. It's a type of average between all of the different ones. Okay, it's called the atomic mass because protons and neutrons are the parts of an atom that carry the most, by far the most weight. Electrons are almost weightless, and yet they take up the most space. That's also interesting. Okay, so on top of that, we've done the symbol. Now just electronegativity. We looked in the previous video at electronegativity as a measure of an atom's ability to attract electrons to itself. So for example, we saw that fluorine only wants one. He really just needs one to be noble. So he has a very high, and as a matter of fact, the highest electronegativity on the periodic table. While when we look at the first group of elements, they only have one extra electron. They are much more likely to give away than to attract. Okay, so that is why they have very low electronegativity, the lowest being 0.7. Okay, that's electronegativity. Obviously, a high electronegativity represents a very high reactive ability, very likely to react, and in that reaction to get electrons. A very low electronegativity is also still very likely to react, but its reaction is giving away its electron. Okay, so that is the numbers that you will encounter on here. Now just the names, what the different groups are called. This first group of elements are called the alkali metals. The alkali metals. Okay, that's what the first group is called. The second group is called the alkali earth metals. I have no idea why. I suppose that's an interesting thing to go and find out, but at this stage I don't know why it's called alkali earth metals. Okay, then all of these in this group here up to that point, that's called transitional metals. Transition metals. Okay, they call transition metals. And then the group, all these ones here, these ones, and then it takes a step down. Okay. No, sorry, I missed the step. Step down. Okay, these are called the poor metals. The poor metals, and these ones, for interest's sake, they also have interesting names. For interest's sake, I will leave them out as not to confuse you. Okay, so the poor metals are these ones, and then we get the non-metals. All of these on this side is non-metals, but that's this group here, specifically their name, non-metals. Okay, and then this group, let me choose more interesting color. Okay, they are called the halogens. That's this group, and then the last group is called the noble gases. We know that already because they think they're better than everyone, and they're noble gases because of in each group, as the temperature decreases, they stay gases. Even at some of the lowest temperatures, they will still be gas, and slowly but surely they'll turn into liquids and then solids. Although even at the lowest temperatures, helium, the lowest recorded temperature, helium is still a liquid. Okay, it doesn't go into a solid. Okay, so that is our periodic table, and as much as I think you need to know at this stage about how to use it in your calculations and in your reaction, writing your reactions. So I hope it was helpful. If not, I'm sorry to have wasted your time. Well, thank you for watching anyways.